the class.
I don't understand the subject. I'll watch it.
Good. So anyways, back to this. My question to you guys, why is this Q, this energy, so much bigger than this energy, right? This is 8,500, this is 57,600, you know, for rounding. So we're boiling, right? So let's say we have a beaker, and in here we have 25.5 grams of water, and it's boiling. That's what that means. We need this much energy to boil the water. Here, say we have a pretty big ice cube, 25.5 grams of water, of ice, and it's gonna start to melt, okay, make a puddle on a table, and it needs this much energy for this to melt. So why, and I'm gonna give you some time to think, why does it take so much more energy to boil, so much less energy to melt? You may know it right now, but just keep it to yourself, think. Let's see what you guys think. Okay, that was 30 seconds. Any ideas? Before I call on somebody? Jake? Any idea why it takes 57,000 joules to boil the same amount of water? It only takes 8,000 to melt?
Because it needs more energy for the forces to break the gas and just for the forces from solid to liquid.
Perfect answer. Full credit. Very good, Jake. Very impressive. Very perfect answer. I couldn't even say it better myself. It takes more energy to break the forces here than it does to, we're not breaking them here, what are we doing? Weakening the forces from a solid to a liquid. See, from here we're going solid liquid. Here we're going liquid gas, right? Liquid gas. So solid particles are this close together. Liquid particles are this close together. You're not really changing much. So it takes just a little bit of energy. Relative, right? It's relative. This, you're taking liquids and breaking them apart to make gas, so it takes a lot more energy. That's why the heat of vaporization of water is 2,000, heat of fusion is only 300. Okay, 300. That's less than a banana. You eat a banana, you get more energy than it takes to melt 1 gram of ice. So if you have 1 gram of ice, it takes less energy than a banana could give you if you eat it. I know that's kind of hard to understand. A banana doesn't give you much energy. Steak gives you a lot of energy, but banana not so much.
Wait, what gives you a lot of energy?
Steak.
It makes me tired.
Right. It's because it takes your body a lot of energy to break it down, but once you finally break it down, you get a lot back from it. You get tired after Thanksgiving dinner, right?
Well, I get tired after.
That's mostly because of turkey, but every time I get tired after I eat too, because I eat a lot. So it all sits in your stomach, and everything, blood and everything goes to breaking it down, so you don't have enough energy in the rest of your body. So you just kind of like,
Yeah. Oh, I know that.
yeah. So, anyways,
Yeah,
that's a similar concept. All right, so more energy here. That was good, Jake. Very good. All right. And anyone else who thought the same thing, good job. Here we go. Number 4 is a doozy. Anyone think they have the right answer? Or they want to be brave and share it with the class? Nobody wants to share their answer?
All right.
Kristen's going to share her answer. How much?
85.
85, she said. All right. I'll let you know if you're right once we start going over it. Anyone else get 85? You got 70.3.
Oh.
Anyone else get 70? 70.3.
Oh.
Well, as for the decimal
It's either really good or really bad.
All right. Here we go.
Mr. McCoy, after
I think I rounded it.
You can.
Oh, I did. I just rounded.
You rounded what?
I rounded mine.
Did you say 85?
Yeah.
They give us 85. Are you looking at the wrong thing?
Oh, wait. Yeah. I don't know what I did. Hang on.
Okay.
Yeah, never mind. Just forget that
All
for
right.
a second. I'll figure out what
I'll forget it. All right, so here we go. I'm going to do this with you. This is how I would attack this problem. A sample of water with a mass of 30 grams. So sometimes I do this. I say, all right, my mass is 30. They told us that. So I write it down. Releases 1,850 joules of heat. Taylor, what's joules mean? Yep. What variable? Q, M, C, or delta T? Q, very good. So my Q, here's the trick. Who's it going to be? Shelby. If it releases 1,850 joules, is that exo or endo? If it releases it, exothermic or endothermic? Releases also means losing. Exo, exiting, releasing, right? So exo, so what's the sign on delta H or Q if it's exothermic? Negative. So this value is negative 1850 joules. If you didn't get this question right because you couldn't set it up, that's fine. All right, that's why we're doing it. And if you tried, I bet if you made a mistake, it's that. It's got to be a negative number. They don't give us a negative here. There's no negative there. There's no negative, right? But it says release, so that's what you have to interpret. So now it says, as it cools, if the initial temperature of the water is 85, what's the final temp? So we know my C is 4.18. We know that. Joules per gram degree Celsius. That's given on table B. Delta T, we know the initial was what? 85. So really, delta T is final, which is X minus 85 degrees Celsius. That's how we're going to solve for the final temp. We know all these other variables. We don't know the final. So now I'm going to take this and plug it into the equation. So I'm going to take negative 1850 equals 30 times 4.18 times X minus 85. That's Q equals MC delta T, right? I'm taking all my numbers and plugging them in. And if you're confused, I'm going to show you how to rearrange it, and we'll do it that way too. I'll show you both ways. How would we solve for X right here? Who's good at algebra? What would we do first? Xavier. Yeah, let's multiply these two together. Does anybody have a calculator? We can do this here quick. Does anyone already have this? 125.4. Everybody stay with me here. 125.4 times X minus 85. Okay. Now what do we do? Let's not do that first. Let's divide first. Let's divide this side by 125.4. That cancels. Divide by 125.4. Who has that one? Negative 14.8 equals X minus 85. Now, what do we do? Add 85. That cancels, add 85. So essentially it's 85 minus 14.8. So X equals 70.3 degrees Celsius. That's our final temperature.
I missed the decimal, so it was.
So you had
It was 12,540, and I was tired and wasn't processing things correctly.
So here's the thing. Friday's test. You may see one like this. I honestly can't remember. I'm not lying to you. But there is a problem involving this. Okay, Q equals MC delta T. I can't remember what you're solving for, but it's one of those variables. Okay, so that's that. I have another worksheet that we're going to do. We're going to practice a little bit more of this because I wasn't here this morning. So period 2 just did that worksheet. We just went over in class. They also did this one, which I'm going to give you right now. And you're going to get with your partner, your pair up, and you're going to work on that. Okay, so pair up. Here we go.
Everybody. Knockout.
I didn't know how.
Shaking in a jar. Way too long.
Is that really?
No, it's cream. But heavy cream in a jar is like salt and just shake it. Or you get butter after a while. We did that. It's the same stuff. It's really like 15, 20 minutes. Yeah, put it in a jar and shake it. Shake it. Like, yeah, got it?
All right. So, here's the deal. Listen. Shh, it's not time to just talk, hang out. Do this worksheet. 73 through 76. The question in the diagram, the picture, is on one side. The questions are on the other. This is a very typical Regents question. Okay, it's right from a Regents exam. I don't remember what year, but so go ahead. You can. The goal here is probably to sit here and work on it yourself, and then when you're done, you can communicate. Or if you're confused, then you talk to your partner. And if you need a calculator, I got them up here. I do not want you using your phone.